Assalamualaikum warahmatullahi wabarakatuh. My name is Adam Haikal bin Azimin and I am from Group 7. I will present about my group presentation about the candle-powered heat engine. The candle-powered heat engine, built using a tin can, demonstrates thermodynamic principles by converting heat energy into mechanical work. A candle heats the air inside the can, causing expansion, which drives movement. Gay-Lussac's principle explains the increase in internal pressure as temperature rises at constant volume, causing an attached membrane or balloon to expand. The first law of thermodynamics, conservation of energy, is applied as heat energy converts to thermal energy and mechanical motion. The second law highlights heat transfer from the high temperature source candle to the low temperature surroundings, driving cyclic motion. This concept emulates heat engines like Stirling engines, solar-powered system, and internal combustion engines, showcasing their application in industries such as agriculture and renewable energy.
Next, we move to the problem statement. The first problem statement of the technology is the low power output arising from the involved technology. Such problems happen whenever candles produce a limited amount of heat energy, hence providing quite a difficult temperature differential necessary for efficient operation. Second is the material and design that will be facing towards suitable successful operation. The materials being used must balance thermal conductivity, durability under thermal stress, and cost. Other than that, compact design can introduce mechanical friction or misalignment, further reducing efficiency. After that, the importance of understanding thermodynamic principle. Firstly, it forms the basis for energy conversion. The thermodynamic principles involved in this project are the first laws of thermodynamics, which ensure that the heat supplied by the candle is accounted for, be it in work output or in energy losses. Furthermore, this experiment had also applied the second law of thermodynamics that dictates the limit of efficiency in converting heat to work. This principle allowed the engineers to find out how much useful work could be extracted from the heat developed by the candle and at what places the losses are occurring.
Next, we move to the discussion. Another problem arises in the indicated amount of the heat transfer on the selected prototype, meaning heat is not being transferred from the candle to the hot side effectively, neither effectively dissipate from the cold side. This could be solved by selecting a material with a high thermal conductivity for the heat-absorbing surface, clean and free from the oxidation to assure maximum absorption. Proximity to the flame by placing the heat-absorbing surface as close to the candle flame as possible without extinguish or sort of build-up. To make an experiment perform, it has controlled the environment to have a minimal air draft by using the heat-resistant material for the setup. It can be assured that the heat loss is at the minimum because of the environment. Lastly, for the conclusion, the candle-powered heat engine project will thus serve effectively to illustrate the certain basic principle of a thermodynamic in the processes of transferring heat, expanding heat, and converting energy. It used the heat produced by a simple candle to convert this into air expanding inside the can, and consequently, it made the balloon go up a direct hand-on view of what actually going on inside any form of a heat engine. Simple as it is, this illustrates the principle of both the Stirling and the steam engine, the cyclic heating and the cooling of a working gas produce work. We will see not only how the temperature and pressure change affect the gas, but also how to convert the thermal energy into mechanical work. That's all. Thank you. See you in our next presentation.